Welcome back to Math Mini Lessons. My name is Sarah, and this is part one of a 2-video review for the New York State exam for 7th graders in New York. So if you're in New York in the year 2024, it is optional for your school to do your exam on computer. So I'm going to do this as if I'm doing it completely on paper. But in the future, we will have exams that are done on computer setting. If your school does this on computer, then I'll make sure to put a link in the description for the equation editor. It looks kind of like this. Let me pause this. I'm going to put this link in here for a question sampler, and you can go to Math 7th grade equation sampler and you can start your test. And this is again just to practice where all the buttons are for when you put your constructed response answers. Now, things that you should know how to do, you should know to hit calculator, and this will be the type of calculator that you'll be allowed to use during the state exam for parts 1 and part 2. So make sure you know where these buttons are. If you need a reference page, you can hit this button for reference, and you'll have the same reference sheet that you would have on the test. So like on the test, you would have this paper, and if you take it on computer, you get the same reference sheet as well. It is kind of big, so a lot of times I change the sizing of it to try and make it smaller to find the things I need to do, and you can just X out. So here's what I can tell you for today's session as you jump on in. This is day 1, which is all multiple choice. I'm going to review the questions 4 at a time, meaning I'm going to give the answers for numbers 1, 2, 3, 4. And then if you have any mistakes, you can go back and make those changes. Just watch those questions. And if you have all 4 correct, just move on to the next section. And I'm going to do that for all of part 1. And once you are done, you reviewed the parts that were either hard for you, that you struggled on, or that you had no clue. Please watch there, and if you have questions, put them in the comments, and I can answer and engage and see if there are other topics or resources I can use to help you. So with that, okay, Math Marbles, let's jump into our first 4 problems. I'm going to start by giving you the answers first and the problem type. And I also have a TI calculator here on the right that we will use for some problems to check work. All right, so for number 1, number sense, you'll get B. 2 is D, it's an algebra problem. 3 is also C, another algebra problem or expressions and inequalities. And 4 is an RP problem, ratios, proportions. The answer is A. So if you have these 4 correct, we'll move on to the next section. If not, we'll go through these problems together. We'll start with number 1. Very simple. We just want to know the value of the expression. So negative 1/3 divided by 2/5. And I'm going to rewrite it as a multiplication problem, 1/3 times the reciprocal 5/2. And I'm getting negative 5/6, since we know we just multiply the numerators and the denominator. And there you have it, the answer for number 1. Let's move to number 2. Maria and her friends are at a movie theater. She has 2 friends. They have $52. They spend $34.50 of it on movie tickets. They also buy 3 drinks that cost the same amount. After buying the movie tickets and drinks, they have $4 remaining. How much did each drink cost? So we're going to start by expressing this as an equation. They had $32 minus $34.50. That's the first thing they did, so I'm going to put that in parentheses. Then they bought 3 drinks. We do not know how much, but we know they're the same amount, so 3x is equal to 4. I'm going to start by solving what's in the parentheses first, and you can use your calculator if you'd like. You get 1750 minus 3x equals 4. Now I'm going to create a 0 pair because I want that 3x isolated. So I'm going to put a 0 pair. So by adding the opposite, this becomes 0, and I have negative 3x. And I have to do the same thing over here to the right. So think about it. You have $4, you owe $17.50. What will that be? And if you need to use your calculators for this, then do that. 4 minus $17.50. And you'll get negative $13.50. Now this will make sense in a moment, because we still have over here a negative 3x. Because I want the x isolated, I know I'm going to use division, but I'm going to divide by a -3. This way, -3 divided by -3 is just going to leave me 1 or 1x, a coefficient of 1, 1x. And I'm going to do the same thing to the 1350. I'm going to divide by -3. And again, if you need to use your calculators, you can. So -1350 divided by -3 gives us 4.5 or $4.50. So the big key here was they want to just make sure you remember your rules for multiplying and dividing with positive and negative numbers. Really important for both of these. If you multiply a negative and a positive, you're going to end up with a negative number. So if they're different, you multiply them, you're going to end up with negative. If they're both the same, you're going to end up with a positive. Same thing if they're both negative, you're going to end up with a positive. All right, so let's go on to the third one, number 3. We want to know which is equivalent to this expression. So I'm just going to simplify the expression. That's all I'm going to do. Start by writing it. 7a minus 8 minus 12a plus 4. I'm going to identify my 2 like terms over here, and let's rewrite this. These are my other like terms. And I'm just going to put them next to each other. 7a minus 12a minus 8 plus 4. And we'll do the first part. 7a minus 12a gives us a -5a. And -8 plus 4 gives us -4. And I can't combine these like terms because one is a coefficient with variable and one is just a term. Now, if you get stuck again and you're super nervous, because let's be honest, when we're taking tests, sometimes our emotions are high and something you know how to do, you may make a silly error on. So if you're unsure in the moment what -8 plus 4 is, again, you can use it here and you'll get your -4. And the same thing with 7 minus 12. If you just want to make sure that you have it, you can. But I know you have this. The more confident you feel, the more in charge of your emotions you will be. Let's look at our ratio and proportion problem. Megan reads the same number of pages each day. I'm going to put this up in yellow. So this is already suggesting a rate per day. We know we're talking about numbers per day, number of pages per day. All right, and we want to see it over the days. How many pages does she read in one day? So this is a unit rate problem. So what we're going to do here, because we want to know the number of pages per day, I'm going to just make rates out of all 4 of these. So we're going to start with the first one, 32 pages over 2 days. And I can simplify that. 32 divided by 2 is 16 pages per day. This should be true for the rest of it because they're saying it's a rate that she reads the same number every day. So let's try it. 64 pages over 4 days is equal to, I'll use my calculator, 62 divided by 4 is 16 pages per day. I'll do the same thing with 80 divided by 5. I know for sure that one is 16. And the last one, 112 divided by 7, 16. So this is a constant rate of 16. All right, so hit pause and jot this one down into your notes. Let's go through the next set, and here are the 4 answers. For number 5 is B, 6 is C, 7 is C, and 8 is B. All right, let's go through these 4. If not, you can keep moving to the next one. For the first one is a number sense problem. I wanted to know which one was equivalent. And so at first I kind of made this problem harder than it have to be, and you'll see it in a second why. At first I started figuring out, well, if what would this entire expression be equal to? And if I can find that number, then I can solve the rest of these and see which one had the same number. So that was the first way I started to approach this. And then when I started solving it, something kind of interesting happened. Because these are all just adding and subtracting, I started rewriting it so that I was like, let me just deal with the whole numbers first, and I'll deal with the fraction at the end. And when I started doing that and solving it from left to right, literally this happened. I did negative 8.5 plus 2.6 plus 2/5, and I stopped and went, wait. That's this one right here. It's the exact same thing, except saying we're going to do these two first. I had a parentheses. That was it. So I was like, oh, the answer is B. So that happened when I stopped and I noticed. But let's say you didn't notice and you kept on going. So probably around here is where you start to get to a little bit of trouble, because negative 8 and 5/10 plus 2/6. So I would have taken out my calculator. I'm going to use my negative sign here in the bottom underneath the answer. Negative 8 and 5/10 plus 2.6, and I get negative 5 and 9/10 plus 2/5. Sorry. Now this is where you get to make a decision. I personally like to make numbers way more friendly, and I literally would have just gone and turned the 2/5 into a decimal and just said, oh, well, I know 2/5 is equal to 0.4, because 2 divided by 5 equals 0.4. And so that was one thing that I just started to do. I was like, oh, just turn this into 0.4. And when I add them up together, I get negative 5.5. Or if you wanted to, you could have just kept it as is on your calculator and did negative 5 and 9/10 plus 2 divided by 5, our little fraction, and you still would have gotten negative 5.5. So that was the first thing I did when I started solving it, and then literally went through all of them to see which one also gave me negative 5.5, and it was B. So I'm going to stop there because there's so many approaches to this problem. All you're looking to see is which expressions were equivalent to each other. Let's carry off. Let's go to the next one. This one also says number sense, but I actually solved this like an equation. Again, two different pathways. You could just go and try to figure out, well, what number here makes this a true statement, and you could have just substituted and done things like negative 2 and 1/10 minus 3 and 6/10, and so you could just do that. And so for the first one, you would have gotten negative 5 and 7/10, and we know that's not it. And you could have gone to the next one and done the exact same thing. So clear, negative 2 and 1/10 minus 0 and 6/10. Negative 2.7, yeah, that's not what I want. I want negative 1.5. And you would have gone to the next one and done the same thing, negative 2 and 1/10 minus out here. So where it gets tricky, minus negative 0.6. So this matters how we're going to type it into the calculator. So I'm going to do negative 2 and 1/10 minus, now I'm going to use a negative symbol, 0.6. That matters. If you put two negative signs, you're going to get a syntax error, or if you put two a minus and a minus sign, you're going to get a syntax error. So here you go. And I get negative 1.5, which is the same as negative 1.5. So that was one way you could just plug and chug and see which one makes it true. The other way, which I actually did, was I really went and just solved it as an equation. Let's give myself some more room here. So this was just, I call it plug and chug. I plugged it in, just saw what was true, but I checked a few of them. And here is my EE way, which is to isolate the variable. So negative 2 and 1/10 minus some number. Actually, I'll use x because I get used to that. Minus x is equal to negative 1.5. So I'm going to create a zero pair by adding. And when I do that, here's, I'm going to get negative x over here. So negative 1, I'm just going to put it in as it does 1.5 because we know that's true, plus 2.1 is equal to 0.6. And now I'm going to divide both of these by negative 1 because I don't want to know what negative x is. I want to know what x is. So when I divide, I'm going to be left with x is equal to negative 0 and 6/10. And there we go. So that's two different ways you can solve this problem. Let's go to number 7. On average, Shantae drinks, this is where it gets tricky, hot spot, half of a 6-ounce glass in 2/3 hours. How much water does she drink in 1 hour? So I do want a unit rate. All right, so the first part, this is where it gets really tricky. What is half of 6 ounces? That's just 3 ounces. So she drinks 3 ounces in 2.5 hours. I want to know how much she drinks in 1 hour. Okay, so I want ounces. Well, I don't want to spell it that way. Ounces per hour. I'm going to make a ratio. Actually, I don't even need to make a ratio table for this. I'm just going to write the ratio. So she drinks 3 ounces in 2/3 hours. I'm going to rewrite that as a division problem. 3 divided by 2/3. And let's turn that into a multiplication problem. 3/1 times 3/2. And that gives us 9/2, which we can solve. 9 divided by 2 is 4.5 ounces per hour. So that's how I got my answer. Again, the hot spot was half of 6 ounces is 3 ounces in 2 hours, 2 1/3 hours. So that's where I started here. And that is my complex fraction. Because it's complex, I just rewrite it in a way that made sense. So 3 divided by 2/3, and then I just rewrite that as a multiplication sentence. Let's move on to number 8. Joel has 3 buckets which contain different amounts of liquid. They're listed there. He mixes all the liquids together, and then he pours all of them equally into 5 containers. How many liquids does he have? All right, so he's adding them all up. So let's write this down. 7.5 plus 5 3/4 plus 6 3/4. He adds all of these up, and then he divides it by 5. That's our goal. Okay, so I have fractions. It's easier for me to add them up if they have the same denominator. So I'm going to just do that. 7 2/4 plus 5 3/4 plus 6 3/4. And then I'm going to divide by 5. Watch how I'm going to do this. I'm going to add the whole numbers first. 7 plus 5 is 12. 12 plus 6 is 18. And then I have 2 plus 3 plus 3 is 8. Okay? I can change that because that's an improper fraction. We can't have that. And I know 8/4 is equal to 2. So I'm going to just rewrite this as 20. So 20 divided by 5 is 4. So this was just checking, do we know how to add mixed numbers when they have different denominators? And notice I had to express it. I know I'm adding first and then dividing by 5. And that's it. Could you have used your calculator for this? Yeah. But the problem is with that, if you were going to use your calculator, it's really complicated to type all the mixed numbers. So I would have just changed them into decimals and done 7.5 plus 5.75 plus 6.75. I would have got 20, and 20 divided by 4. All right, hit pause and jot this down before we go to the next section. Here's the next 4. The answer for 9 is D. 10 is C. 11 is C. And 12 is A. So for number 9, we want to know, here's some scores. What is the mode? So we're looking for the mode. And how does it compare to the median? So when you look at the numbers itself, you're looking for the mode that is most frequent. And in this case, 82 comes up the most times. So my mode, here we go, is equal to 82. Now we need to find the median. If mode was most frequent, our median is our middle number in an ordered set. So I have to put all those numbers in order. I'm going to give myself a little bit of space here on the bottom. 45, 65, oops, see, I already missed one. 63. 65, so I'm going to cross out. Okay, 74, 76. And now I have to write 82 3 times because I have 3 values with 82. And then 90 and 93. So there are tons of hotspots here. With one, just copying down the numbers, I made 2 mistakes. So I try to just take my time and just write out the numbers since you have a bunch of time for this test. Now, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So I'm going to start by crossing out 1, 2, 3 over here, 1, 2, 3 over here because I want the number in the middle. And I'm going to cross another 1 here, and here I have 2 numbers in the middle, so I need to find their average. Actually, let's be more specific because there are tons of different averages. I'm going to find the mean of both numbers, which means I'm going to add them up, divide it by 2. So with our calculator, 76 plus 82 is equal to 158, and that I'm going to just hit divide, so my answer divided by 2 gives me 79. All right, so my mode is 82, and my median is 79. So when I compare them together, 82, or my mode, is bigger than my median, and that's why A and B don't work because my mode is not 79. That's not true. And C doesn't work because my mode is not lower than my median. So cross that out. Okay, let's go to the next one. And here I have a box and whisker plot. It's sometimes called a box plot, which is called here. I call it box and whiskers because these look like whiskers to me. All right, so we're going to try and figure out which statement is true about the distance in miles. And as I'm reading through them, because I can't do anything till I can just go through the problem first, and I'll start eliminating. So the first one, it says the interquartile range, so my IQR for bus drivers is 2 times the IQR for teachers. So is the first IQR 2 times bigger than the second one? So is that true? All right, so my IQR for my bus drivers, that means I want to know from this number, which is 10, because I can see it right here, 10. And my second one over here is 20, from 10 to 20, okay? So let's cross this out for a second. So for bus drivers, my IQR is 10. And for my teachers, it goes from 15 to 30, which is, well, 15. So is 10 equal to 2 times 15? Nope. 10 is not equal to 30. So let's go to the second one. The range of the distances for teachers is twice the range for bus drivers. This is just really wordy, and so there's just a lot of places to be tripped up. So we want to know the range for teachers is 2 times our range for bus drivers. So for teachers, it goes from 5 to 35, so that range is 30. So is 30 2 times for bus drivers is going from 5 to 30, which is 25. And no, because twice 25 is 50, so nope, they're not equal. Let's look at the next one. Again, tons of hotspots. You just have to slow down and think carefully. My IQR for the bus drivers is 5 miles less than the IQR. So whatever it is for teachers, minus 5. All right, so for bus drivers, it goes again from 10 to 20. So that's 10 is equal to, on this side, from 15 to 30. So that's 15. So 15 minus 5, 5 less. So 10 is equal to 15 minus 5, to 5 less. So that's why C is true. You can see how tricky that is, because I had to look at the bus drivers was 10, and then I had to take the distance for the teachers, the IQR for teachers, and do minus 5. So that is a true statement. And the last one is incorrect because it says the range for teachers is 5 miles less than the range for bus drivers. And the range for teachers, it goes from 5 to 35, so that's 30 is equal to 5 to 30, which is 25 minus 5. No, that's not true. 30 is not equal to 25 minus 5. So that one was tough, and you really had to look at it one at a time and really figure out. You had to know where your interquartile range was and what a range was. And all the doubles and the 5 less, that's what was tricky. So this one is interesting, and again, I want to take my time and look through this with you. This one gets a little bit more complicated. A worker at a snack box opened a new box of cups. The first day, the worker used 30 cups. The second day, the worker used 15% of what was left. A total of 90 cups were used on the second day. What was the original number? So this is a percent change problem. So let's go through it piece by piece, and I'm going to try to write this as an expression. So on the first day, there were 30 cups. This is the first day. And then on the second day, he used 15% of what was left in the box. So 15%, so I'm going to express that as 15% as a decimal. So 50 times whatever was left in the box. So this is the second day, and this is 15% of whatever that number is. And we know that the total cups used on the second day, a total of 90 cups were used the second day. What was the original number of cups? Okay. So I'm going to start by looking at my second day, and he used 15% of some number is equal to 90. And we have no idea, but we know he used 90. To isolate my variable, I'm going to divide both of these by 15% written as a decimal. So I'm going to do 90 divided by 0.15 or 15%. And that is 600. Okay, so that makes sense. He used 90 out of 600. And 90 out of 600 is 15%. So if you actually do this, 90 divided by 600 is 15%, 0.15. Now, so that's how many cups there were the second day. We want to know the original number. How much did we start off with? Well, we know on the first day he had 30, and we know the second day there were 600 cups. So if I added those two up together, so I had used 30 used, plus the 600 hours left on the second day, that's how I'm getting 630. This is a very complicated problem. It is a two-step problem. I need to figure out how many cups there were on the second day, which I do. There were 600 cups the second day, and I know we used 30 cups the first day. So I know my original number was 630. All right? So lots of little steps there. This was a very tricky problem. Let's go to the next one, number 12. Which expression makes the equation for all values of x? Okay, so this one, again, a little tricky. I need to figure out which of these expressions can I put into this space, and I'm going to get that equivalent expression. We'll make it true. So I'm going to try putting these terms in there. Oops. And I'm going to see which one of these is really going to be equal to 6x minus 16. Or 16x minus 16. So 4 times the expression 2x minus 2. 4 times the expression 12x minus 12. So let's see which are true. Now I'm going to distribute. 4 times 4x is 16. Yep. And 4 times negative 4 is negative 16. So the first one is true. If you tried the next one, you get the first term correct, but 4 times negative 16 is not 16. So remember, you distribute to both. So that's what we're looking for, a kid who doesn't distribute both of them. In the second one, 4 times 2x would have given us 8x. So that would have been your first clue. And in the third one, 4 times 12x would have given us 48x, which would have been your clue. All right, so that's the next set of 4. Hit pause, make any corrections, and we're going to move on to the next section. All right, for number 13, the answer is B. 14 is D. 15 is A. And 16 is C. So again, I wrote the domains on the side. Here are 4 answers. If you had any incorrect, keep watching. If not, keep going to the next section. The first one for number 16 is an RP problem. 13 table shows the amount of money in dollars Kathy earns for babysitting. Based on the table, which statement is true about the relationship between the hours and the money she earns? And these are asking about proportionality. So how do I know if it's proportional or not? The easiest way is I can see whether or not all of these relationships, D to H, if they are equivalent. So are they all equivalent? And I'm going to start with the first one, which is 50 over 4. 6250 over 5 is the second one, and I'm going to test these out. So I'm going to do 50 divided by 4. I get 1250 per hour. And the second one, 6250 divided by 5 is another 1250 per hour. So this is amount of money per hour. Let's do the next one, 75 over 6 and $112.50 over 9. So I'll do the same thing. 75 divided by 6, $12.50 per hour. And the last one, 112.5 divided by 9 is equal to $12.50 per hour. So this is actually proportional. So they do have a proportional relationship. So I know I can eliminate A and C automatically. Now for B, it says they're proportional because the ratios between the values of D and H are the same for each pair. That is true. The ratios are the same. They all simplify. They have the same unit rate of $12.50 per hour. This is true. For D, yes, they are proportional. That's true. But it says the reason is because the same amount from one pair of values to the next. It increases by the same amount. That's not true because if I'm looking at it here, from 50 to 6250 is going up by 1250. But the next set isn't going up by 1250. Well, is it actually 75? Let's really check that. Because I know, yes, 6250. Let's clear it out. 75 minus 6250. All right, so that one increases by 12.5. Let's look at the next one, though. I knew one of these didn't. 1250 minus 75 high is 3750. So there it is. So the first two were the same amount, but that third one is what makes it not true. So there you go. I knew I was in there because I did these before I did the video. So hopefully that makes sense. It's not just they're proportional, but the reasoning had to be correct as well. For number 14, I want to know which of these represents a proportional relationship. Again, that means that all of these had to be proportional to each other. So thinking about the y over x, they would have to be the same when you simplify it. So for the first, or just equivalent fractions. So for D, I can see that 1/5 is the same as 2/5. 2/10. I know that is true. But let's say you didn't know. So here's 2/10. Here's 3/15. Here's 4/20. And here's 5/25. These all simplify to 1/5. So I can divide 3 and 15 by 3, that's 1/5. Divide 4 and 20 by 4 over 4, which is 1/5. So they all simplify to 1/5, so that's what makes it true. For all the other tables, there is at least one pair of numbers that makes it not true. And that's the challenge. So for the first one, I know I would get 4/3. And then I get 10/6. Do these simplify the same way? So try it out. 10/6. And you can even use your calculator if you need be. You can do 4/3 is equal to 1.3 repeated. 10/6 is equal to 1.6 repeated. So right then and there, that one you can eliminate. Doesn't work. When you go to B, we'll do the same thing. We get 6/12, which simplifies to 1/2. And the second one, you get 12/14. No, that simplifies to 6/7. These are not equal to each other, so B crossed out. We'll go to C, you get 2/4. And next you have 4/8. So far so good, they both simplify to 1/2. And then you get 8/12, and nope, that one simplifies to 2/3. So that's not true. So there you have it. So you have to look to see, and notice how they'll put some numbers in the beginning that will work, and then as you keep going, you have to check that the entire table is proportional. And if you can find any of them that makes it not true, then it ain't true. Let's go to number 15. Clara goes mini golfing. She pays $7.50 for an admission ticket and $6.25 for each round of golf. So that's important that she has a rate here. And we know what the given rate is, $6.25 for each round. The total amount she pays for admission and the tickets is $26.25, which equation can be used to determine X. All right, so we know that she pays $7.50 once, plus $6.25 for every round of golf she plays. We don't know how many, so that is my X. And I can see here, this is my rate, $6.25 per game. And X is the number of games. And she has $26.25. So the only one that matches is this one here. Except it just means my terms were switched around. So it's still equivalent if I have $7.50 plus $6.25x, $7.50 plus $6.25x. The second one doesn't work because, of course, there's a subtraction sign. And these don't work, C and D, because my rate, it is not $7.50 per game. Okay, let's move on to the next one, 16. And we want to know which statement is true. So it's another box plot. And so there, of course, we have to know how to find all the terms, medians, ranges, and interquartile ranges. So just so you see, the median is that line that's inside the box. That's my median. If I want to find my interquartile range, then I find the distance from the two outsides of the boxes. That's my IQR. From there to there, what's the distance from there to there? What's the difference? If you want your regular range, again, you're going from all the way from your two whiskers. That will give you your entire range. Okay? And again, we're looking to see which one has everything true. So the answer for this one is C, the interquartile range for B is greater than A. And for B, my IQR is going from somewhere between here to here. And it's kind of hard to see the numbers, but just looking at it, this is smaller than B. B is just bigger. So I know this is bigger than that one. So that is what makes it true, even though the numbers are kind of hard to look at. And let's look at why the other ones don't work. All right, so the median for A, the median is greater for A than B. Well, here's the median for A. Here's the median for B. B is bigger. It's just a bigger number, so no. We'll go to the next one. The range for A is less than B. Just by looking at it, you can kind of see that A is bigger than B is. But if you want it, so it's about 65 to 95, so this one will be about 30. And for the second one, it's going from 75 to 100, which is 25. So that's not true. A is not less, A is more. The range for A is more. And then for the last part, you had the second quartile value for B. Okay, so here's my first quartile, my Q, oops, here we go. That's my beginning. Here's my Q1. Here's my Q2 or my median. And then at the end of the box is Q3. And then the end over here is Q4. So the second quartile value for B is less than for A. So is this number less than this number? Just by looking at the number line, no, B is not less than, A is much bigger number. All right, so you can hit pause and jot this down. So this one, it was more being able to look at it and identifying the key parts of the box plot. And some numbers you can kind of work through, but you may have to estimate. Okay, let's do the next 4. For 17, the answer is C. 18 is B. 19 is C. And 20 is A. If you need to go over them, stay on. If not, move forward. With the first one, you want to know the distance of X between each parking lot space. All right, so I want to know what this number is over here, and I know that the distance between each car is the same X. And I could also see that one car is 8.5. So that means that these are all going to be just the car distances: 8.5, 8.5, 8.5, and 8.5. So I'm going to rewrite this as a sentence, but at first I would just be writing 8.5 plus 8.5 plus 8.5 plus 8.5 plus 8.5. I'm just going to write 5 times 8.5. And I also have 1, 2, 3, 4, 5 X's. Oh, it's 4 X's. So I'm going to combine those terms. So I have 4 X's. And do I know anything else? I know the total distance between all of them is 50, because it said so right here. So this is an awesome problem because it's very visual and you had to get all that information to write it up. So again, I'm just combining like terms so I can work through this problem. So 5 times 8.5 gives me 42.5. I'm going to actually write 42.5 with a decimal. Plus 4x is equal to 50. I'm going to create a zero pair by subtracting 4250. So I end up with 4x is equal to 7.5 or 7.50. And now I'm going to divide by 4 to get x. So 7.5 divided by 4 is equal to 1.875. Now, this is where it can get a little tricky, right? Because, hey, I kind of wanted the number as a fraction. So this is what you could do. If you end up with something like this where you're getting just a big number, you're like, wait a minute, I'm not so sure. Let's change that number back into a fraction. And I want to give myself some space, so I'm going to put it over here at the top part. So 7.5, and I'm going to divide it by 4. So let's rewrite that. 7/2 is going to be 7.5 times 1/4. I'm going to change that 7.5 to a mixed number. So 2 times 7 is 14. So 15 halves times 1/4 is equal to 15/8. So I still got to change it to a mixed number. 15 divided by 8 is equal to 1. And that leaves me with 7/8. And there's my answer for C. So there you have it. I didn't like this because I was getting 1.875. And even if you put that over 875 over 1,000, you'd have to simplify it to 7/8. Or you could have just decided, all right, we'll deal with the fraction and do the division work. Let's go on to number 18. Ooh, this is an inequality, I believe. Or let's see. A student has a bus pass with a balance of $30. Each time he rides the bus, the balance decreases by $2.25. So every time, that's going to be important. Each time he rides the bus. So that means I'm going to have a rate. So $225 per ride. What is the greatest number of rides the student can take? All right. So we know he has, let's write this out. So $225 for every ride, X. How, not equal to 30, but we know he has $30. So the 30 has to be the most or equal to. So how many rides greater than or equal to 30? I can actually still solve this using an equation. I'm going to isolate for X. I'm going to divide by 225 to leave me with X. 225. Clear. So 30 divided by 2.25. Oops. 30 divided by 2.25 is equal to 13.3333. It just keeps getting repeated. So I can have exactly 13.3 rides, but in real life you can't take a decimal point of a ride. So at most I can do 13 rides. I can't do more than that, because if I do 14 rides, then I just don't have enough for my bus pass. And if you want to check that, you can just do 14 times 225 and see that would be $31.50. So I can't do 14 rides. I can do 13 rides though. 13 times 2.25, and I had $29.25. So I have enough for that. Let's go to number 19. Which expression is equivalent to -18 minus 64? And so I have 4 sets of expressions, and to find out their equivalent, I'm just going to distribute. That's what I'm going to do. And the reason why C is the answer, -2 times 9 is -18. -2 times 32 is -64. And so that's my correct answer. Only difference is they just put a parentheses around this. So boom, there you go. If you tried distributing the other ones, one of the terms would not have matched. So there you have it. B and D wouldn't have matched because you would have gotten +18 as a first term. And for A, you would have gotten -18, and -2 times the -32 would have been a +64. So that's why A wouldn't work. Let's go to number 20. Which expression, so I like how even though it's an expression, it's still a number sense problem. Which expression can go in the blank to make the equation true? So in other words, I have to take that whole expression and put it in to this blank to make it true. So what I'm going to do, and I know that they're going to equal to 0. So this is where my thinking comes in. And so what I decided to do is I'm going to combine these like terms. And -4 5/10 plus 4 4/10 is going to give me -1/10. So let's think about this for a second. This is equal to -1/10 plus some number gives me 0. The only way I can get 0, and this is why it's a number sense problem, is I would have to add the opposite. Okay, so this expression over here has to be +1/10. So which of these, when I actually do the math, is going to be equal to +1/10? Only that first one. So I put a minus sign, -6 7/10 plus 6 8/10 is equal to 1/10. And that would give us, that works because 1/10 plus a -10 would give us 0. And that's it for that one. You can try all the other ones, but they're not going to equal 1/10. So hit pause, make any corrections. We're going to go on to the next 4. Here are the answers for the next 4 problems. 21 is C, 22 is D, 23 is D, and 24 is C. So jot down those 3 answers, those 4, C, D, D, and C, and we'll start going over them together. Starting with 21, a store sells blue hats and green hats. Each hat is priced at $8.
The expression of 8B plus 8G can be used to determine the total price when the customer buys any number of blue hats and any number of green hats. Which equivalent expression could be used to determine the total price in dollars of the hats? So let's start by jotting this down. So we have 8B plus 8G. And we want to know which expression is equivalent to the ones on the side. And the one that is equivalent is this one, C, because if we distribute and multiply B by 8, you get B8 or 8B. And then if you distribute again, 8 times G, you get 8G. So these are equivalent to one another. The reason the other ones aren't equivalent, 8BG just means 8 times the number of hats that are blue times the number of hats that are green, so that doesn't work. 16, no, they're assuming that kids are combining these terms together, which you can't because they have different variables. And D makes the most sense because if you distribute it, we can see that you get 16B plus 16G, and that's not equivalent either. The next one is an inequality problem. Manny goes bowling. He has $25 to spend. Automatically, as soon as I hear that, I know it's going to be an inequality because we can't spend more than $25. So my head is already going, we can spend exactly $25 or less than $25. So keep going. It's $4.25 to rent shoes, and we know that only happens one time. So it's a constant. And for every game, he spends $2.50. So 250x, where x is equal to the number of games. All right, so how do I express that? So again, we already know he can spend equal to or less than $25. We know that the shoes is just for $25 one time, and we know that he can spend $2.50 per game. So I'm looking for an inequality that matches this. Now remember, it could also be written as 250x plus 425 is less than or equal to 25, or I could put the 25 on the other side and it flips the symbol around. So any of these. So just look at the terms, and the first two we know we can eliminate because it says it has the reverse sign where we can spend more than $25. And C we can eliminate because we only pay for the shoes one time, so that's not 4.25x, it would be 250x. Let's move on to the next one. Yeah, this was the only one that completely matched our work. All right, a store manager. This was a spicy problem, really spicy. He collects information about the number of people who visit his store each week. So 3 weeks of information. In week 1, there were 3,200 people. In week 2, there were 10% more than week 1. So we have week 1. Then in week 2, we have 10% more than week 1, which is whatever this number is. And then in week 3, we have 15% more than week 2. So whatever this number is. And we need to figure out how many people visited on the 3rd week. So I want to know, what is this number? What is 15% more than week 2? Well, I can't know week 2 unless I figure out what is 10% more than week 1. All right, so let's figure that out. In week 1, we had 3,200. We want 10% more, which is, well, 10% more would be 110%. 110% of 3,200. And I'm going to express that by turning 110% into a decimal and just multiplying it by 3,200. So 1.1 times 3,200, and that is equal to 3,520. So now we know week 2. For week 3, we want 15% of 3,520. So I'm going to do the same thing. 15% more is 115%, or 1.15 times 3,520. So 1.15 times 3,520 gives us 4,048. And there it matches D. So that was spicy. That was definitely spicy. It had multiple steps, but here's everything. So jot it down into your notes. And remember, if I want 10% more, I'm going from 100% and just adding 10%. So that's 110%. If I wanted 10% less, I would do 100 minus 10%, which would be 0.90 or 90%. So that's just something to keep in mind. And it's going to be really helpful in this next part, number 24, which is also kind of a spicy problem. A regular priced item at a store is P dollars. So whatever the price is P dollars. The item is on sale for 20% off. So that is the same as saying 20% off of 100 or 80% of the price. All right, so we want to make sure those two distinctions are there. And if you're a salesperson, a lot of times you'll put 20% off because 20% looks like that. Think about what that number looks like, as opposed to say 80% of the price. So there's some psychology going there. So some of the expressions shown below represent the sale price in dollars. Which two expressions each represent the sale price of the item? So what I'm going to do here is I'm going to figure out which one of these is equivalent to 20% off a price. So think about that. That would be, if we know the price is P, so P is equal to 100% of the price. So I could take 20% off, so I can do minus 20%, or I can represent that as P minus 0.20 P. So this is one way I can express this. Do any of these match? Yep, D right here, that matches. What could be another way I could express this? Well, let's, because I have 1P, even though the 1 isn't C, what if I had 1P minus 0.20P? I could simplify that further. And 1 minus 0.20 is equal to 0.8. So I could also write this as 0.8P, which is the same as 80% of P. So what we had before. We had that. So this is our next equivalent expression. Do we see it anywhere? Yep, I see it here in B. So those two are the ones that are equal to 20% off. And they match over here. Okay. So of course, because we have to look for B and D, for the first one, it's completely off because it doesn't include those two. And it doesn't make sense. This is saying 20% of the price. That's not the same as 20% off. This one has 1 minus the 20%. So could you have chosen this one? Could you have chosen? See, it looks very, very close, doesn't it? But notice the difference. This is saying 1 minus 20% of P and not P minus 20%. So that's why this one does not work. That is not the same as P minus 20%. And the bottom one, this would be P minus 80%. So this is 80% off. Not the same as 80%. All right, so hit pause and jot this one down into your notes as well. Yeah, this one was spicy. Here's the next set. 25, the answer is B. 26, the answer is D. Another percent problem. 27 is D. And 28 is C. So we have some ratio problems, a percent problem, and looks like a geometry problem, so that must be scale factor. All right, let's start with 25. Joseph has a part-time job. The graph below represents the amount Joseph earns in dollars for the number of hours he works. Based on the graph, which equation can be used to determine the earnings in dollars for every hour he works? So we are looking for dollars for every hour. So dollars per hour. This is a rate. So I want to know the unit rate when he works for 1 hour. What is the amount when he works for 1 hour? So I'm going to look right here in the 1. And that happens over here at this point here. And actually I'm going to zoom into it so you can see it a little bit more. And in 1 hour, he spends $15. Okay, let's zoom it back out. I wrote a percent part by accident. So 1 hour, he spends $15. And I can represent that as 15x. So there we go. So you could always just look for the unit rate, follow when x is 1. And that will give us our unit rate, which we also represent as this coefficient here. All right, let's go to the next one. At a store, a hat has a regular price of X dollars. During a sale, the price of the hat is discounted by 20%. So we already saw something like that, right? Where it's 20% off. So it can be expressed as 0.8x describes the discounted price in dollars of the hat, which expression also describes the discounted price in dollars of the hat. So we just did something very similar to this, didn't we? Where we knew that we had 20% off, which is the same as the regular price. So 100% of the price, or here it is, this is what it will look like as a decimal. This is what it will look like as a percent. There we go. And we're taking 20% off. Oops, yeah, so 20x. This is the same as taking off 20%. And if we just subtracted those, we would get 0.8x, which is the same as 80% of the price. Okay, so that's what we're looking for, and I could actually see this expression right here. All right, C is very close. It's just missing the X, so that's why we can cross it out. 20 is not written as a decimal or percentage, and we can say that an A is just 20% of. That's not 20% off. Right? Let's go to number 27. This one's a scale problem. Danielle constructs a scale model with a rectangular base, and her model is 2 inches in length and 1 inch in width. So I'm going to just draw that. So 2 by 1, and these are inches. I'm going to use that little symbol. And the scale of the model is 1 inch is equal to 47 feet. So what would be the area? So this one's actually pretty simple, since we can redraw this out. Since the one side is 1 inch, that means that this side over here will be 47 feet. And on the bottom part, it's 2 inches, or 2 times 47, which would give us, I believe it's 94. Let's triple check that. 2 times 47, which is 94. All right, so those are our dimensions now in feet. And so if I want to find the area, all I have to do is 47 times 94. 47 times 94, and we get area is equal to 4,418 square feet. There you have it. D is the only one that works. A grocery store sells sliced turkey. The graph shows the relationship between the weight of the sliced turkey and the total cost of the turkey. So we know that there's some type of relationship between the weight and cost. And just looking here, because we know we're thinking about y over x, our y is the cost and our x is the weight in pounds. So we're looking for the price per pound. So which statement about the graph would be true? So we're looking at 2 points, point R, which is up here, 410, and point W, which is 1.25. And we already know that when we find the cost at 1 pound, that this is going to be the unit rate. So we already know that. Unit rate. So that would be our W. So which statement is true? Point R is the unit rate? No. Point R means the unit rate. Again, no, it doesn't matter what the numbers are. For C, point W is a unit rate, which is 250 per pound. And that's what I see here. 2.5 or 250 per pound. That is true. And point W means the unit rate is 2.5 pounds per dollar. So here they just had these reversed. That doesn't make sense. So that's why D is incorrect. So C is the correct answer. Hit pause and jot this down before we move into the next section. All right, this is the final home stretch, the final 4 problems for the multiple choice section. Remember, EDs are all worth just 1 point. So 29 is B. It's another rate problem. 30 SP, the answer is A. So some stats. 31 is C. And 32 is also an RP problem. And the answer is B. So jot these down. So it's going to be another percentage problem. And we're going to start with 29. All right, 29, we see a graph which has the total distance in miles traveled over time in hours. So again, if we're thinking y over x, we're looking at the miles per hour. Which statement best describes point F? So point F, I could already see it is at this 1 point, so we already know it's going to be a unit rate. So knowing that already with the first one, A, it says it's a unit rate in hours per mile. We know that's not what it is. That's the reverse. B, it is the unit rate, so that is true, in miles per hour, which we worked through. So B is the correct answer. C doesn't work because that will show time in hours for 1 mile. That's not true. This is 1 hour, not 1 mile. And D doesn't work because it says this has 5.25 hours when we know that 5.25, the y coordinate, is miles, not hours. Let's move to the next one. Hopefully those are getting easier to just recognize. When you see the graph, you should be able to identify the unit rate immediately in the proportion. Okay, this one, I have a feeling we're going to need to use our calculators because it is a stats problem. Alright, so let's get our stats brains ready. The researchers surveyed 5 randomly selected employees for each of the 4 different companies about their daily commutes to work. The table shows the commute times for the surveyed employees. Based on the data, which company most likely has the longest average commuter time per employee? So all we're looking for is which company has the highest average. And the average we're looking for is the mean. Okay, so that means we're going to add up all those numbers inside and then just divide them by the number of data surveys. So here we're going to add up all of these and then we're going to divide by 1, 2, 3, 4, 5. That's the goal, to figure out the average. So let's start by just adding them up. I think I already added them up, and when I added them, I got 121 is the total. And I'm going to divide by 5 for this one. So oh, wait, I think I actually get 122 divided by 5. So 122 divided by 5, and you get 24.4 for the first one. For the second one, when we add all of these up, our total is 99. So 99 divided by 5, it'll be just under 20. So their average is 19.8 minutes. This one's the easiest one, C, because they're all the same. So 15 plus 15 plus 15 plus 15. I know when I'm going to add them all up and divide by 5, I'm still going to get 15 because it's an even. They're completely even. And this last one, when we add all of them up together, we get 95 divided by 5, and that's going to give us 19. So A makes the most sense. So hit pause and jot this one down into your notes. All right, let's go to the next one. Here we have a line plot. How many players are represented? So I like this one. We just want to know how many players are represented. So I just want to know the number in the sample. And so I'm just going to count all of these here. So here I have 3 plus 1, 2, 3, 4, 5, 6, 7 plus 7. That's already 10. 1, 2, 3, 4, 5. 5 plus 4 plus 2 plus 5 plus 1. All right, so I'm just adding all those numbers together. I like to add numbers together that are really friendly. So those two make 10 plus another 10. And then 4 plus 2 is 6 plus 1 is 7. So 27. That's all they were asking. So that one, easy point towards the end. And here we are, the last problem. Whew! Get excited, get your energy kind of going. Last part. And it has a percentage in it. The bill for dinner at a restaurant is $58.20, and this is before tax and tip. The sales tax is 5%. The tip is 20%. How much is the total bill? Okay. So I'm going to show you, I think I could actually show you two different ways, but I'm going to show you the first way that I find is the easier. So let's kind of break this down. We know the dinner is $58.20. And then we're going to add the tax to that. The tax is 5% of the dinner, or 0.05 times $58.20. And then the tip is 20% of the dinner, or 0.2 times $58.20. Now, you could do these separately. So you could absolutely find all of these numbers separately. So 5% times $58.20 is $2.91. And 20% times $58.20 is $11.64. And so we can add all this together to find the total. So that's dinner plus the tax plus the tip. All right, so let's do that. 58.2 plus 2.91 plus 11.64. And all this would equal 72.75. So that is dinner plus tax plus tip. There it is. B. Done. Now, there is a second way that I can show you that also works. Because remember, same method, we have $58.20, which is our dinner. Then we want the tax, which is 5% of the dinner. So let's say I wrote this as 5% of whatever the dinner costs. And then we want the tip, which is 20% of the dinner, which is the same as 0.20 times whatever the dinner costs. So what do you notice here? I notice that here I have some like terms because I want 5% of the dinner and I want 20% of the dinner. So you could have just added those two together because I have the same variable and just did 58.20 plus 0.25% of the dinner cost, or 0.25 times 58.20. So you could have done it in this one step and gotten the same answer. So 0.25 times 58.20. So 58.20 plus 14.55. And that would also give you, when you add them up together, 72.75. Same answer. So notice here the only difference was I just noticed that if I wanted 5% of dinner and 20% of the dinner, I can just add them up and figure out, well, I can just multiply that by 25% of the dinner. So that's the second way. I'm going to give you a third way to think about this. When we think about tax and tip, and a lot of adults struggle with this. So you can even show your mom and dad that this works, because adults are like, what? They always see this in separate parts. I see this one. All right, so think about this for a minute. We have the dinner, the cost for dinner, D, plus our tip or our tax, which is 5%, of D plus our tip of 20% of the dinner D. So watch this. Our dinner is right there. D is just 100%. So 1D for 100% plus 5% of the dinner plus 20% of the dinner. Now these are all like terms. So you could simplify this to 1.25% of the dinner and do this in one shot of 1.25 times 5820. 1.25 times 5820 to get 72.75. Done. So when you're going out to a restaurant and you already know what your sales tax is and you already know what your tip is, the only thing you have to know is the cost of dinner. In New York, I think sales tax is about 8.8%. So let's round it up. Let's say in New York, the tax is 9%. And tip, obviously, that depends on the type of service. I generally give 20% tip. So I already know that whatever the dinner is, I know that my dinner, I'm going to automatically times it by 1.29% to figure out what dinner plus tax and tip cost. So that's just my way of doing it. And it's separate. That's, I think, how a lot of different countries do it. They give you the bill all at once, instead of just splitting it up and figuring out what they could each be. But that's it. That's the end of this last lesson. I just wanted to show you have 3 different ways of figuring out 2 different percent increases, because in both cases we're increasing by the same number, which is the dinner. So there you have it for today, Math Marvels. This was day 1. It is a monster of a test in 7th grade, but you do have your calculator. In the next video, we're going to go through all of day 2, which has some more multiple choice and then some constructive response. I'll see you in the next video, Math Marvels. Be well. And if you have questions about what you saw today or other topics you want to see, add them into the comments and just let me know. Hey, can we go over this type of problem? Can you do a quick short on something? And we can make that possible for you. All right, Math Marvels. Till next time.